Hi there. Welcome back to episode 5 of For Crying Out Cloud. This is our discussion of Thunderstorms, part 2, and you're here with Miss B. In this episode, we're going to be discussing thunder, lightning, and thunderstorm safety. Now, lightning is an electrical discharge caused by imbalances in a storm cloud and the ground. And most lightning occurs within the cloud or between clouds. During a storm, you have particles of rain, ice, or snow that are inside storm clouds. They create friction when they bounce off of each other. Now, you've done this yourself. You have created static by rubbing your shoes against the carpet, and then you touch someone else and you shock them. The same thing happens inside of a thundercloud. So this friction creates an imbalance between the storm cloud and the ground, or between two storm clouds. Now, the things on the ground or the other cloud become positively charged, and the cloud becomes negatively charged. Now, nature always wants to be in balance, so it passes the current between the negative cloud and the positive earth so that the positive and negative cancel each other out and it can be neutral. You can see in this diagram, you've got the updrafts and the downdrafts. We talked about that in part 1. Well, all the particles in there, all of the ice particles, hail, rain, all of that stuff in there is rubbing up against each other as they get blown up and down. As they do, they create friction, just like you rubbing your feet on the carpet, and that becomes static electricity. That's going to make that snap or that discharge of electricity. Now, most lightning is going to jump from cloud to cloud or intra-cloud, which means inside of a cloud itself. So the lightning bolts are going to jump from the positive part of one cloud to the negative part of another, because they want to be in balance, or from the positive part of a cloud to a negative part within itself. And when they cancel each other out, that's when you're going to see the flash of lightning. So you can see in this photograph, this would be intra-cloud lightning inside the cloud, jumping from one place to the next. And this would be cloud-to-cloud lightning, jumping from one cloud to another. That's the most common kind of lightning there is. So you can see in this animation, you can see it jumping within the cloud. You've probably seen that during a summer day or a summer evening as a thunderstorm passes through. Cloud to ground lightning is a little more dangerous. That begins when a step-like series of negative charges races from the bottom of a storm cloud towards the earth. Now, that electricity coming out of the cloud is about 200,000 miles an hour. That's really fast. And each of the segments is about 150 feet long. Now, they call it a stepped leader. Now, think back to being in preschool and kindergarten, and you drew a piece of lightning out of a cloud in one of your drawings. You probably drew it with zigzags. You didn't realize how right you were. That's why it's called a step leader. The zigzags actually look like stair steps coming down from the sky. Now, when that step leader comes within 150 feet of something on Earth that's positively charged, the ground, a tree, anything, there's going to be a second stroke. I bet you didn't know there were two parts to lightning. Not just this stepped leader that we've seen before, but there's a whole nother piece that comes up off of the ground on Earth. And that is called a streamer. You can't see it, but it's there. And that's the electrical charge racing up from Earth to meet the step leader in the middle of the atmosphere. Now, the second that connection is made between the two of them, that's when you're going to see the huge discharge of light. And that discharge is the flash of lightning. Now, that air that it goes through, when that flash happens, it's about 50,000 degrees Fahrenheit. That's hotter than the surface of the sun. That's why lightning is so dangerous. So you can see in this diagram, you've got negative charges down here at the bottom of a thundercloud, positive charges from the earth. These are the streamers. This is the step leader. And where they meet, in the middle of the air, that's where the lightning flash happens. So you can see it in this slow-mo. If you watch very carefully down here, right before the flash, when the step leader comes down out of the cloud, right before the flash, you'll see the streamer meet up with it. It's actually a little easier to see in this animation, or stop motion, sorry. You'll see as it comes near Earth, where they make the connection is the lightning bolt. So here you can see negative, positive, where they meet creates that flash of lightning. So you've got negative, positive racing up, where they meet is the flash. This is actually easier to see. So here would be your step leader. Here's your streamer. Where they meet in the middle creates the flash. Now there's always streamers coming up from Earth. There are always step leaders coming down from the clouds, but they don't necessarily always meet up. Where they do meet up, that's where you're going to see the flash of lightning. So the rapid heating and cooling of the air near that lightning channel, that's where you're going to get a shock wave. And shock waves make a really loud sound. And that explosive sound or the rumbling that you hear, that's the sound that lightning makes when the step leader and the streamer meet. And that explosion is the discharge of electrical particles. And you always see lightning before you hear the thunder. And that's simply because on Earth, light travels faster than sound. You can figure out, however, how far away the lightning strike is. And I'm sure you've heard of this one before about counting the seconds. You count the number of seconds between the flash of lightning and the sound of thunder, but most people stop there. There's a second part to this calculation. After you count the number of seconds, you have to divide that number by 5. That's how you get the estimate of how many miles away the lightning strike is. This step is most important because otherwise the lightning's closer than you think it is, and you're in grave danger. Let me give you an example. So you see lightning flash, and you're going to count, and you count 10 seconds between the flash and the rumble of thunder. If you stop at this step, you're going to calculate that the lightning strike is 10 miles away. That would give you a little bit of time to be able to get to safety before there's the possibility of you being struck by lightning. However, your calculation's incorrect. When you divide by 5, you are going to find out that the lightning strike is only 2 miles away. A lightning strike 2 miles away is far too close for you not to be in danger. So you need to remember to do that second part after you count how many seconds between the flash and the thunder. then divide by 5, and you'll know exactly how far away that lightning strike was. Now, the heat that comes off of lightning, it'll vaporize the water inside of a tree and create steam that'll blow the tree apart. Now, most tall buildings, skyscrapers, are grounded by these special rods called lightning rods that conduct the electricity right into the ground. Homes are usually grounded by plumbing, gutters, and other materials. So most buildings that you're in, sturdy buildings, they offer you protection. But you can't touch running water, use a landline phone, or any other corded electrical objects. You can get in your car, absolutely. It offers protection from lightning because the tires and the metal frames will actually absorb the lightning and put it harmlessly right into the ground. You will not be electrocuted inside of a car. Now, about 2,000 people are killed worldwide by lightning each year. That's honestly not as large a number as you really would think it is. Most survive the strikes, but suffer from a variety of lasting symptoms, including memory loss, dizziness, weakness, numbness, and other life-altering ailments. When you get to John Glenn, there's going to be a teacher who's my best friend, and she was struck by lightning. She will tell you the story of how she was struck by lightning, and she will explain to you what kind of ailments and things that she has because she was struck by lightning all those years ago. Now, if you get struck by lightning, it can cause cardiac arrest, which is a heart attack. It can cause severe burns, but 9 out of every 10 people actually survive. Getting struck by lightning does not necessarily kill you. An average American has only about a 1 in 5,000 chance of being struck by lightning in their lifetime. So the odds are not in your favor. So here's some of the electrical strikes that can happen to you. Now, if we were in class, I know you'd be giggling at this because I giggle at this every time I see it when you watch the guy. So a direct strike is exactly that, getting struck directly by the lightning. You become part of the main lightning channel. Most often, if you're going to get struck by a direct strike, you're in an open area or you're near something very tall, and that's going to attract the lightning. So it is the most deadly because the current goes right through the skin, goes right across your skin, goes through your heart, your nervous system, and it really does destroy all those systems. Now this one's called a slide flash, a side flash, or a side splash. And a side flash occurs when something hits a taller object, the lightning will hit a taller object, and part of the current actually bounces off that other object and angles into you. It's another reason you don't want to be standing by anything tall during a lightning storm. Now, a ground current strike happens when the lightning actually does strike the ground. And that energy travels outward from the strike along the ground, and it affects a really large area if it happens. And you can see in this guy, it's actually coming up out of the ground and straight up into him. For the most part, this doesn't happen very often to humans, but it does kill a lot of large farm animals because they have a large body span, and the greater the distance between the lightning contact point and the exit point, that's where you get the greater chance for death. Now, conduction. Conduction is one you really need to worry about. Lightning travels all kinds of distances in wires, metal surfaces, and water. Metal and water don't attract lightning, but they conduct electricity very well. Their molecules are very close together. So they provide a path for that lightning to follow. So whether you're inside or outside, if you make contact with anything connected to a metal wire, to plumbing, to electricity, metal surfaces, or water, you are at risk. So when there's a lightning strike, don't touch anything that plugs into an electrical outlet. Don't touch water faucets, showers, corded phones, windows, doors, anything like that. Don't be in a body of water because water conducts electricity. If the lightning hits the water, it is going to race through all the molecules in the lake or the pool that you're in. The fifth one and the final one is called a streamer. You already know that streamers are the pieces that come up from the earth. Now, typically only one of those streamers is going to make contact with the step leader that comes down. You saw that in an earlier animation. But sometimes you can be where another streamer is coming up from Earth. And even though the lightning channel didn't get completed from the step leader to the upward streamer from Earth, you can sometimes get electrocuted just by being where that streamer is. But this is the absolute rarest of all the lightning strikes. So if you don't learn anything else from me this school year, this is the most important thing you need to learn. Because no matter where you go on Earth, you are going to encounter thunderstorms. And thunderstorms can be deadly. So always avoid open areas and stay away from isolated tall trees, towers, utility poles. That's where you get the side flash lightning strike. It bounces off of that tall object and then gets ricocheted off to you. Also, don't be the tallest object. The step leader is always looking for the streamer, and if you're the tallest object, the streamer's going to come up through you. Stay away from anything metal, like wire, fences. Metal doesn't attract lightning, but lightning travels long distance through all metals. Keep away from all electrical equipment because lightning is electricity. It's going to want to find other electricity. Sensitive electronics like your computer shouldn't be plugged in when you have a thunderstorm. Water's a great conductor of electricity. Get out of the pool, the lake, the river, the ocean, any body of water that you're in. And don't take a bath, shower, or use other plumbing during a thunderstorm. It can come right through the pipes. Fully enclosed buildings with wiring and plumbing provide the best protection. Places like your house, places like a school, places like the mall or a restaurant, those provide really good safety. Places like a shed or a picnic shelter or a tent or a covered porch, that doesn't protect you from lightning. The chance of you getting struck, especially by conduction or side flash, is pretty high. And so if a sturdy building isn't nearby, get into a hard top metal vehicle and close all the windows. If it strikes the metal, it will go around the outside, down to the tires, into the ground, and you won't be electrocuted. One last thing I want to point out to you is there is lightning that occurs above a thundercloud. It's something most people don't know as well, and honestly, we've just learned about these in the last 30 years. So above a thundercloud, going out into space, you have a couple things going on. One of them is a blue jet. And a blue jet pulses from the top of an intense thunderstorm and reach up to the edge of space. The other thing you can have is a red sprite. They glow up in the upper atmosphere and they come from large lightning flashes. So these are above the thunderclouds. They're going out into space. And these have been filmed from the International Space Station. There's another kind that is a halo created in the ionosphere, and it's called an ELV. And this ELV is kind of a green halo that is created. So this is all above a thundercloud, and you see them out in space. So here's your questions to think about. What is lightning? How is lightning created? So explain how friction's involved in that whole thing. True or false? When nature balances out positive and negative charges, the results become neutral. Where does most lightning occur? How fast does cloud to ground lightning move? What is the term for the channel of energy that comes down from the cloud toward the ground? What is the term for the channel of energy that comes up from the ground toward the cloud? When the two channels of energy meet, what happens in the sky? How hot is the discharge of lightning? What are the three types of lightning that occur above clouds? True or false? Thunder is the sound that lightning makes. Why do you see lightning before you hear thunder? How do you calculate the distance of a lightning strike? Why is the second step of dividing by 5 so important when you're calculating the distance of that lightning strike? How many people die each year by being struck by lightning? And how many survive? What are your chances of being struck by lightning? What are the 5 ways that lightning can strike people, and which one of those is the most dangerous? Why is it important not to be near tall objects or be the tallest object in an open space during a thunderstorm? Why should you stay away from metal and electrical objects during a thunderstorm? True or false? You are safe in bodies of water like lakes and pools and other water sources in your house like faucets and showers during a thunderstorm. True or false? You're safe in an enclosed building like a house or school during a thunderstorm. True or false? You're safe in a shed, picnic shelter, tent, or covered porch during a thunderstorm. And lastly, true or false? You're safe in a hard-topped metal car during a thunderstorm. So I'll leave you with this meme. And I'll tell you that the questions for this is on a Google Forms that I will attach. And I will also attach this Google Slides presentation for you to be able to go back through to answer the questions. Stay well, stay safe, and I'll see you soon. Bye.